Well, welcome one and all to RAC's question time, extra time. This is on the subject of A2L refrigerants for cold rooms. It's the third in our extra time series, so we are glad that there is such interest in tackling some of the cooling industry's most important issues. We're grateful to TUV for sponsoring this, and you'll hear from them as the morning progresses. We're also delighted to be joined on the panel by some of those leading the real-world take-up of A2Ls. Indeed, in some cases, leading the world in real-world take-up. I'm also delighted that so many of you are joining us, and I encourage you, as this is called question time, to put your questions to the panel via the box on your screen. We have learned through experience two things about this question process. Firstly, keep the questions short so that I can read them to pose to the panel. And secondly, don't press return until you finish your question, because Zoom is no respecter of paragraphs. So without further ado, let me welcome Chris Chisman to the virtual stage. Chris.
Hello. My name's Chris Chisman from TUV Limited. I'm the Technical Director, and I'm going to run through the first presentation. Just give me a moment to share my screen. Hold on. Just getting there. A second. Just start the slideshow off. And it's just coming up. Okay, excellent. So yeah, good morning. Thank you for joining me on this presentation for A2L for cold rooms. What we're going to talk about? Well, first, a little bit about F-gas, not too much because I'm sure we've all heard lots of it before. Then we're going to have a look at refrigerants in terms of why we've chosen the refrigerants that we have, why we're looking at A2Ls. A trip through the relevant standards in terms of A2Ls and cold rooms. Then I'll start to talk through our cold room system match solution and how we developed it, how to select it, and its key benefits. Finally, I will also give a bit of information regarding other A2L projects that we're working on. Okay, so the F-gas regulation. Not going to spend too much time, but the key point is the GWP phase down and the 79% reduction on 2015 refrigerant GWP levels by 2030. This means by 2030, the average refrigerant GWP needs to be 400 if refrigerant volumes are to remain the same as 2015. Or more pressingly, there's another reduction coming at the end of this year, making the average GWP needed to be 900 from January 2021. Okay, so refrigerant considerations. So what makes a good refrigerant? Well, obviously it can't be corrosive, and also, preferably you don't want it toxic or as little flammability as possible. Good environmental properties in terms of low GWP and not ozone depleting, and good fluid and thermodynamics, so you get good capacity and energy efficiency. Unfortunately, there's a balance to be had. We have to make a compromise. For instance, if we have the option of using a refrigerant which is slightly flammable, then it gives us the potential for better efficiency. So what happened last time when there was a phase down? Well, we all experienced a massive increase in price in refrigerant. There's been a correction since, but the next phase down of refrigerants, for refrigerant volumes to remain the same, the high GWP refrigerants must become more expensive, and the new lower GWP refrigerants become more popular for refrigerant volumes to remain the same. Brexit and coronavirus will probably have an effect on this, but we all hope that will be temporary, whereas the GW phase down is here to stay. So what are A2L refrigerants? Well, to help meet the F-gas phase down, we needed something new. So a new category of refrigerant was developed, the A2Ls. This allows slightly less stringent refrigerant charge restrictions within the regulations. So more refrigerant is allowed than, say, flammable refrigerants such as hydrocarbons. The example shown here is our 454C. So future refrigerant selection. So we needed to select a refrigerant to suit the F-gas phase down for 2030 and beyond. We know 448, 449 and 452 are all in current use, but with GWP levels of 1300 or above, something needs to change. Our 513A is an interesting option. It's not flammable and compressors are coming available, but it's actually a 134A alternative, so its capacity is very low, and ultimately it doesn't get the GWP level down as low as where we need it to be. Other refrigerant like R470, which is also an interesting option, but again, with a GWP of 717, it doesn't get the GWP down low enough. So when it comes to refrigerant options, we chose R454C and its Honeywell alternative R455A. They're A2L class, so flammable, so less flammable than hydrocarbons, and the GWP is down at 148, so very much future-proof. There are also several compressors and components start to become available and certified for use for these refrigerants. So for us, it was a sensible choice to take. So now we're going to do a quick trip through the regulations and standards. So are flammable refrigerants dangerous? Well, yes, it's flammable, so it can sustain its own flame with the right mix of oxygen. So the risk of a potential flammable atmosphere is real. However, this risk can be safely mitigated through the control of ignition sources and limits on refrigerant charge levels. There's also information out there on how refrigerants can be safely designed into systems within current standards. So working with flammable refrigerants, from a regulatory point of view, I can get my words out, installers just need an F-gas certificate to buy it and use A2L. However, from a company risk assessment point of view, we would strongly recommend that engineers attend a flammable refrigerant course before using A2Ls. Obviously, it's also important for installers to abide by the regulations and follow manufacturer's instructions. Risk assessments. All current refrigerants are pressurized and have a toxicity level, so should have a risk assessment. However, flammable refrigerants, this becomes even more important. So we've worked with consultants and we provide a risk assessment template within our instructions to guide installers. So now we're going to have a quick look at EN 378. So from a manufacturing point of view, this is what we've used as a standard, and specifically the table referring to refrigerant charge for A2L refrigerants. I'm now going to go through step by step how we've classified our equipment within the standard and what the refrigerant charge limits are for cold room refrigerants, for cold room equipment. So the first step is access category. There are 3 types. There's general access, supervised access, and authorized access. But for equipment that we want to sell ultimately through distribution for use in the general market, we don't want to add any extra restrictions. So we've chosen general access, which is less restrictive to end users. The next classification, so what's next, is location classification. So class 1 is compressors and pressure vessels like receivers in the occupied space. This could be like a water-cooled condensing unit. We've got class 2, which is compressors and pressure vessels in open air and coils and pipework in an occupied space. This is a split system. Class 3 is all parts in the machinery room or open air. So this would be like equivalent to a chiller. And the final one is class 4, which is ventilated enclosures, which for a cold room you want to try and to avoid. So obviously what we're looking to in terms of cold room split systems, class 2 is where we're at. So where does this leave us with the maximum charge? Well, within general access, there are 2 categories: human comfort, which is for air conditioning, and then other applications, which is obviously for refrigeration, which is where we are for cold rooms. So when you work your way through the table, this gives us the limit relative to room size of 20% times the LFL times the room volume. We're also given an overall maximum charge limit, which calculates to 39 times the LFL. There is an alternative classification allowed, but this is for multi-splits, i.e. for multiple cabinets in a shop, on the shop floor. So this can't be used for what we're looking at, which is single split cold rooms. So what does LFL mean? Well, it stands for lower flammability limit. It's also sometimes referred to as LEL, lower explosive limit. And what it means is the minimum quantity of refrigerant in a perfect mix with air to be flammable. So in a 20 cubic meter room, R454C with an LFL of 293 grams per cubic meter, you need 5.86 kilograms in a perfect mix to be flammable. However, in reality, you don't get a perfect mix, which is why there's the safety margin of 20%. This calculates to only allowing 1.17 kilograms of R454C in a 20 cubic meter room, which I can tell you that's not a lot of refrigerant. The maximum allowable refrigerant for a split system 39 times actually equates to 11.4 once you go to, you know, as big a rooms as you can get. So developing the testing, what have we done in terms of developing our new A2L split system product? Well, on developing and testing, we've been working on the project for the last 2 years and testing for the last 9 months. This includes work on reducing the refrigerant charging systems, for example, running on expansion lines. We've tested different system matches, so we know exactly what the refrigerant charge requirement is for each. And we've also improved the efficiency of the system by 3% compared to our original condensing units, which are already some of the most efficient on the market and are listed on the ETL website. And it's only through all this work that this allows us to offer a 5-year parts warranty, giving peace of mind to the end user. So engineered quality and reliability. So here we have like an exploded view. I'm just picking out a few key points. Firstly, the unit has a fitted expansion valve in the condensing unit with the driver and display. It's preset and can run independently like the thermal expansion valve, but you can control superheat much more efficiently. And with a fitted display, it makes it easy to adjust. Second, the externally enclosed electrics box removes all the potential sparking components from the compressor section within the unit. And third, we've used compressors designed specifically for A2L, so in terms of reliability. So selecting units, how do we select systems? Well, our easy selection guidance gives the following outputs. We can calculate what the evaporating condensing unit product selection. We use the duty and the temperature requirements for that. Then we calculate the suction and expansion pipe sizes from the condensing unit selection and pipe run length. The required refrigerant charge. What we do is we add together the unit base charges and then add the requirements for the pipe work. Then we calculate the minimum cold room size based on E378. And then finally, we do a desired free volume assessment within the cold room, calculates how much free volume should be kept within a cold room to ensure the flammability won't be breached. Idea, so, in terms of overloading a cold room with spark. Okay, so this is just a quick table to remind ourselves of the stringent sort of charge limits on refrigerant. A traditional system with a receiver charged to a sight glass is just going to require too much refrigerant. Also, traditional cold rooms are generally sourced with the evaporator and the condensing unit supplied by separate manufacturers. This is going to make it very difficult for consultants and contractors or distributors to specify A2L cold room systems, knowing that they will be within the limits and of the standards. So here we go. This is the table I've been sort of building up to. This shows the very low refrigerant charge levels required for our new critically charged A2L system match products. It also shows how easy it will be to select an A2L system match. And you know that you will be within the regulations for refrigerant charge. For example, on the third line down, this is a 1.9 kilowatt system, and at a 10-meter run, this needs just 510 grams. That means it's suitable for a room as small as 8.7 cubic meters. It's also stated, we also state we provide guidance for the free volume within the cold room, so it can be discussed with the end user at the specifying stage. All the work we've completed on our critically charged systems allows us to offer systems with refrigerant charge levels down low enough to meet the stringent requirements within the standards on a reasonable length of pipe run. Okay, so we're just going to do a quick run through the key benefits. First, let's break down the improved energy efficiency. Remember, Master already offers units that are on the ETL listed. These systems are even more efficient. So for a typical 3 kilowatt system, you save approximately 175 kilowatt hours per annum. Not only does that save money to the end user, but that's a 60 kilogram saving of CO2 or 1.2 tons during its 20-year life. These CO2 savings obviously increase with the number of units installed. So when we get, hopefully thousands of these units out there, for 10,000 units, that saves 12,000 tons of CO2 over their lifetime. Remember, this saving is just due to energy efficiency. Clearly, the bigger benefits are with the refrigerant GWP saving. So if we compare a typical 449A, a 3 kilowatt system on approx a 10-meter pipe run to the new R454C system match, combining the reduced refrigerant charge with the reduction in refrigerant GWP, this gives a 93% reduction which equates to 3 tons of CO2 per system. Extrapolating that over 10,000 systems, then that saves 30,000 tons of CO2, which obviously makes a massive difference in helping the industry meet its obligations. Okay, risk assessments. So this is important to point out that we've worked with independent consultants who are experts in the field. And what does this mean? Well, it means we provide an installation risk assessment template within our instructions, covering all aspects of the installation. We also provide the DESIR free volume guidance that we showed earlier. And for this, we've used EN 60079-10-1, which through the assessment of factors such as the potential leak rate of refrigerant, the free volume requirement has been calculated. We also provide other guidance, including, what to do with leak detection, alarms, and what to do in the event of a refrigerant leak. So just a quick recap on the developments. We offer cold rooms. We offer cold room systems, not just individual condensing units, which is important. It's only through this we can know the charge and calculate the free volume requirement at the specification stage. Yeah. Secondly, we've reduced the refrigerant charge level down to a minimum. This ensures the maximum pipe run relative to cold room size is available. We've changed the design of our units to ensure compliance. We are using compressors and components that are approved for use with A2L refrigerants. This obviously, again, this helps us with our 5-year parts warranty. We include a risk assessment template within our instructions to help contractors with their installation. And the A2L system match will be suitable for a family of refrigerants, R454C, R454A, and R455A. To summarise the key benefits then, this is a simple skill uplift for contractors. It will be very similar to what they already know. We just recommend installers complete a short course on the use of flammable refrigerants, whereas alternative solutions such as CO2 require a much greater skill uplift in terms of skills, training, and equipment as well. The contractor on these systems can continue to use the controls that they're familiar with. The wiring is very, very similar. System selection will be simple, as can be seen from the table we showed previously, in terms of using your room size, the capacity, pipe run, refrigerant charge. Massive environmental benefits in terms of improved energy efficiency and the huge reductions in refrigerant GWP per system. We also have, cost effectiveness. The A2L system costs will be much closer to current normal A1 systems, and also, the big differences in terms of, compared to alternative green options such as CO2. So this, along with the improved energy efficiency, gives a very low total cost of ownership for the end user for such an environmentally green solution. We also give installers all they need for full compliance within the box. So basically, we're helping them. They don't need to fend for themselves. So finally, we're just going to have a quick look at what else we're doing. So on the future development, we've just launched our A2L system match products. These will be for cold rooms. These are medium temperature, 1 to 6 kilowatts. What's next? Well, we're launching cellar cooler range on A2L, and this will be in October of this year. And then we'll also be launching an extended range of medium temperature and our first low temperature range in early 2021. Finally, we're also investigating partnering with cabinet manufacturers to see what we can do in terms of single split cabinet options. And all of these A2L systems will have the major development improvements and key benefits that I identified earlier. Okay, so obviously we're in the webinar now, and there'll be obviously a series of questions, but if there's anything after the webinar that you want to contact us directly on, then it's just sales@marstair.com. Okay, that's me done. Over to you, Andrew.
Well, thanks very much, Chris. What we'd do at this point normally is we go straight over to the panel, but as there's a very specific question come in, I'm going to throw it straight back to you, Chris, because it's hopefully very simple for you to answer and possibly impossible for the rest of the panel to answer. And what size of your monoblock system would you need to cool 2 to 3 tons of food, and what's the approximate energy requirement per hour?
That I would, off the top of my head, that is a bit much.
That's an easy question.
I think that's a sort of, if they send it through and give us the email and the details, then we'll size something up for them, definitely. Yeah. Okay, But off the top, normally we'd use a calculator for that, and that is, you know, I can't compute that level of maths just off the top.
Well, when this seminar is over, you'll probably be able to answer the question on that. You'll be able to type an answer through the power of technology. I'll leave that up there. Okay, so at this point then, let's get the whole panel together and we'll say hello. I think we're going to get a couple of slides to begin with, but we'll do the introductions first. So we're delighted that joining Chris on our panel is leading consultant James Bailey of Wave, who has been very involved with A2Ls. There he is. Hello, James.
Morning.
And I would say he needs no introduction, but I have to introduce him. It's a contractual obligation. Brian Churchill of Asda, sitting in front of his green screen. Now, I think Brian is going to give us the first volley from the panel because world-leading exponent at the moment of A2Ls in practice. So over to you, Brian. We'll go on mute now, and the floor is yours.
Thanks very much, Andrew. Yeah, so I thought it would be worthwhile and useful to just share a few slides with you on the webinar. And Chris, thank you very much for your presentation. It was very informative and a great piece of work there. So real quickly, I'm just going to give you a little bit of a whirlwind tour of kind of Asda's position on technical development. Probably looking about 6 or 7 minutes to go through this information. So for food retailers, a lot of us know on the attending this webinar, it's a real complicated area for us. We're trying to fix one issue, whether it's ozone depleting potential, life cycle costing, regulations, F-gas regulations, so on and so forth. But we try and address that issue, and inevitably 2 or 3 other issues pop up. The whack-a-mole effect is probably the easiest way to describe it, and is generally a never-ending issue for us. Within the F-gas regulation, we've been extensively replacing refrigerant gases in existing systems. The analogy would be a blood transfusion. So taking out the high GWP refrigerants, putting low GWP refrigerants back into those systems, which actually have driven a return on investment for us because we do get greater energy efficiencies by doing that replacement. But inevitably, we know that we're going to have to do an organ transplant within our estate, which is replacement, fundamental replacement of all systems in our estate. So what do we replace those systems with? So over many years now, we've trialed multiple technologies, probably over the last decade or so. I do need to reiterate that this is a position of being led by data, not views and opinions. So innovation and technology development is absolutely welcome by Asda in every way, shape and form, whatever that technology is. But ultimately what it comes down to is we need to make sure that that technology which we're replacing within our estates at the moment will add value to the business, not only financial value, but sustainable value as well. So it has to be a cost-effective system that will reduce energy, reduce risk from a trading perspective, and really add value to the customer by reducing the cost to operate those systems. So on this slide, you can see a bar chart. The bar chart, so A in red is our current model standard, which is our latest and greatest 448A design, looking at total cost of ownership. And then we have multiple technologies that we then desktop evaluated and then measured in a live environment to cross-reference the performance of those systems to really give us an understanding of where those measures sit should we make that technical change. Interestingly, columns D to H would, from a life cycle perspective, put us in the wrong direction from a life cycle costing perspective, and this was found out quite early on in our development. This then led us to identifying other opportunities with our consultants and technical support base, where we started investigating HFO technology more widely, and another technology that Asda's developed with our partners at City, the Mistral display system. And really was the reason why we then drove forward with an A2L or an HFO design standard. We can all see just energy consumption in isolation versus the other alternatives. And then we can also see annual emissions, CO2 equivalents on that basis. So again, just reiterating that we are technically agnostic business. We are led by the numbers, we are led by value, we are led by value to our customers. And that's really what drives our decision and our choices within the regulation and also requirements to reduce our environmental impacts. On this slide, more specifically, if you look at the F-gas regulation, which the slide that Chris showed earlier, you can see the phase down of F-gas. To Chris's point, you get to a point eventually around 2040 where you need to be below 400 GWP average. The blue line in the bottom left-hand graph is actually showing our projected reduction, which is clearly projects and shows not only are we on track to meet that requirements, but certainly as we head to 2035, we'll be well below the F-gas regulatory standard. And that's using a combination, a projected combination of the adoption of an HFO technology combined with a mix of Mistral in our estate and any other potential technical solution that we may want to install back into our existing estate. Top left-hand graph shows the migration as we move away from HFC refrigerants across to the HFO Mistral combined system, and you can then see over that period how that will be replaced systematically out of our estate. And then just a few pictures then to the right-hand side of that. And then just finally, without the data, you're just another person with an opinion. So being data-led on all this information is critically important to ensure that we are making the correct and the right decisions for the business. Our HFO or A2L development started about 2 years ago with a team of global technical experts. The same expert consultant that Chris was referenced in the work that TEV had done has been helping support us through the development of our HFO standard, A2L standard. And is going very well for us. And again, the energy savings that Chris is referencing there are almost identical to the energy savings that we're seeing. And energy is critically important, as is safety. And just one last thing, Chris had mentioned around an ideal refrigerant being non-corrosive, non-toxic, non-flammable. Probably one to layer into that, which our compliance team in Asda are very keen on, is also being non-explosive. And is very difficult because we do know the lower we reduce the GWP of refrigerants, you ultimately end with explosive, flammable, and toxic refrigerants. So you do have to be very careful around which refrigerant you will choose. The A2L refrigerant for us, from a design perspective, so long as we're following the DESIR assessments, is academic. In reality, it's a very different situation. Our compliance teams are very happy with the developments and the approach that we're taking with this. And there's a compendium, a technical compendium of information that we've created, around 1,000-page documents that sets out design standards for what we've done, which will all also be presented to the International Institute of Refrigeration in the middle of July. Okay, so that's a quick 6 or 7 minute whirlwind view of what we're doing out here in Asda. I would just reiterate again, technically agnostic is our position. Innovation and more than just one technology for the future will drive a lot more competitive edge in the market and will drive innovation. Thanks, Andrew.
Thanks very much, Brian. Now, the idea is that we will be answering some of the audience questions in a minute, but first of all, we're going over to James to get a little bit of the consultant perspective on A2Ls. I mean, I guess one of the prevailing themes is everybody feeling comfortable with the new refrigerant. So you want to take us through from that point of view, James?
Yeah, as Brian mentioned, we engaged on this journey probably 3 to 4 years ago now, and we looked at various alternatives, and in terms of A2L, and we were guided to 454 XL40, which is a Chemours product. Although it's got a GWP of 238, we like the close capacity match that we were seeing when compared to Asda's existing architecture, which is very much follows scroll compressor technology. The one thing that struck us was we have to be guided by 378 and the charge restrictions that are presented within there. What we found very quickly was with Asda's existing architecture, specifically around medium temperature systems, they operate with nominally eight scroll compressor pack systems. The development initially from the design, we looked at, well, if we look at an 80 kilowatt nominal 8 scroll compressor system, we'll be circa around 130, 140 kilograms of refrigerant, even on relatively short runs. To match the requirements of 378, what we determined was if we split those packs, so effectively, if we look at the image behind Brian, that is an Asda A2L HFO pack design. Effectively, you can see multiple arrangements, so you can effectively see on the outside, you've got 2 discharge headers. So effectively, we've got 4 scroll compressor systems which are back to back. So effectively, there are 2 pack systems within that arrangement. That lends itself really well to the Asda architecture in terms of retrofit, which Asda are embarking on and will be embarking on quite intensively in the coming years to ensure that compliance remains to F-gas. The big factor as well, it's what we found by splitting the systems. We obviously reduced refrigerant system charge volume, but we had to take it to a further level as well. So the systems that you see there, we've adopted microchannel condensers to a great deal of success. And obviously the refrigeration pipework services that are feeding the fixtures, display cases on the sales floor, we're now using much smaller size services, because as opposed to a typical Asda which nominally is an 8 scroll 80 kilowatt capacity, we've now got 2 40 kilowatt capacity units, so that reduces the refrigerant charge volume. So where we found ourselves at the moment in terms of development and the trials and the rollout that's ongoing at the moment, nominally the system charge are below 50 kilograms of refrigerant in each circuit, in each system. We calculated, based upon the similar rationale that Chris showed in his presentation, that for our 454A, we'd be looking around a 54 kilogram maximum capacity to ensure compliance. We've also taken a very much a belts and braces approach in terms of from a safety perspective. So for example, every single display cabinet has its own leak detection point. We've got leak detection points surrounding the pipework, and naturally we've got leak detection within the plant, where we do find that although Asda's leak rates are very, very low, what we have found is that the majority of leaks will always be at the high side of the plant. So to this day, with the systems that are out in the field at the moment covering five stores, we've certainly not suffered any refrigerant leaks or anything of that magnitude. And the first installation post trial at Asda Trafford Park in Manchester, that is coming up to its first 12-month anniversary. What we found when we compared it to a 448A system, which is also on the same site, which is loaded very similarly in terms of refrigerating one of the islands of display cases, we're currently finding circa 4% energy benefit over 448A as well. And obviously they layer on top of the significant emission savings, the direct emission savings, because now we're dealing with a fluid with a GWP of 238, as opposed to in excess of 1200, which is the current Asda model with being R448A. And I think that probably ends where I'll need to be here, Andrew.
Jolly good. Well, thanks for that, James. It's interesting to hear about the energy benefit, because energy always comes up in the questions. I'm sure it will in a minute. I guess we could start Chris, if you want to come onto video now as well, and we'll start the panel proper. But we might as well tackle the elephant in the room straight away, because again, one of the questions that will always come up with A2Ls, I don't know whether either James or Brian wants to tackle it. Isn't the question, isn't A2L a bit environmentally damaging? Do we know anything? Do we know enough about it yet? I mean, how did you approach that whole piece? I guess that's one for you, Brian.
Well, the energy performance benefits that you get, it's actually environmentally supportive, because of the energy associated to carbon emissions is anywhere between 80 and 90% of the total carbon emissions of the refrigeration system. The actual refrigerant gas itself equates to around 10 to 20% of the emissions. So ignoring the energy performance benefits, not only the kilowatt hours, pounds and pennies we pay for energy, but also then the associated carbon benefits reduction far outweigh the associated direct emissions. And a point that I've made for many, many years now is that refrigerant leakage is unacceptable and should always be unacceptable. You don't go into a petrol filling station to fill your car up expecting there to be smells of petrol all over the petrol filling station. You know, it's beholden on the industry to ensure that the standards are set correctly around leakage. We then select the refrigerants of choice based on the best value possible, which is driven by energy performance, and that's exactly what these refrigerants give us. So certainly from a GWP perspective, we see it that the selection of a refrigerant based on its energy profile performance is very, very important, because as I say, it's 80 to 90% of the associated carbon emissions. Granted, in the UK, we're doing a great job of decarbonising the national grid, but then adverse to that, we are still paying for the kilowatt hours, any additional kilowatt hours, and our targets are very much energy intensity based in terms of reducing our energy intensity.
Okay, thanks. Let's deal with 2 or 3 questions about new product. So over to you, Chris. Here we go. So firstly, if a leak is repaired on the system, how do we ensure the engineer doesn't exceed the system design charge?
Well, I would say, first of all, in terms of a proper F-gas engineer that will have installed it in the first place, they have to keep a log, and supply that log of the equipment in terms of what the refrigerant charge was. But the other key point is that it's a critically charged system. So in order for it to operate correctly, you have to put the correct charge in terms of knowing where you are in terms of the product. So it's not like, there's a receiver in there where you can overload it with extra refrigerant. You have to put the right amount of refrigerant in to make it, work the way you need it to be. And as Brian says, leaks are unacceptable. You get the right critical charge, the system will operate correctly.
Okay, thanks. The second one is the compressor a scroll or a BLDC type?
So at the moment, the compressors that we're using basically scrolls for the larger, basically fixed speed scrolls for the larger units. And then on the smaller units where the scrolls are not available, we go down to sort of reciprocating compressors.
Thanks. And then the final one for you at the moment is what noise levels are you getting at the moment, and are you looking at lower noise versions?
So at the moment, from memory, the range, it's around about, and this is a fairly technical answer, so technical question, so it's a fairly technical answer. Basically, it's around about 30 to 35 dBA at 10 meters anechoic is around about where we are in terms of noise level. At the moment, we're focusing on getting the product ranges out. And obviously, we know, there's certain applications where noise is important, and we are looking at that as well.
I think you can give your straight back standard answer is, if you'd like to talk to you, and you can talk them through it in specifics, to heart's content later.
Yeah.
I think we're going to get a few of those. You wait to the one that I've got for Brian, because I can barely say it, let alone read it. So Brian, the cabinets you use in your stores for A2L, certified according to EN 378 or, I've got to read this out carefully, to IEC 60335-2-89.
So as James had mentioned, the display case design and just generally the design of the refrigeration system using an A2L is really designed to an A3 standard at the moment. So all ATEX rated standards have been met. All design risk assessments have been undertaken using the DESIRIS risk assessment. So I don't know if you want to add anything to that, James, but we've really gone above and beyond in terms of design.
Well, I think that's a really good question. So just to reiterate what you said there, Brian, everything within the systems at the moment, all the switchgear are all rated to, it's all ATEX rated equipment throughout from the evaporator fan motors through to the plant, which is absolutely critical in terms of ensuring that we don't have a flammable zone. So effectively on the plant side of the system, we've looked at the electrical componentry within a cabinet, which is housed in a secondary arrangement as well, just to prevent, in the event of any leak, any ingress. But as I say, all the switchgear is, at this moment in time, we've gone ATEX rated for everything throughout. So it's very much been a belts and braces approach.
I think it's fair to say that as we're going through this development piece and we continue to review the standard, because there is no standard for an A2L, what we're already starting to identify are opportunities to actually pull that specification back from an A3 standard quite significantly. Because of the risk assessment experts that we've got involved in this are actually seeing opportunity here, whereby there is certain componentry that we've been using at ATEX rated that are saying just not necessary. You go back to Chris's point that he made earlier about understanding what low flammability actually means. It's a very tight window of opportunity where a flammable environment can be created. Too much oxygen, it won't ignite. Too little oxygen, it won't ignite. And you need the right amount of ignition source, heat, energy to be able to ignite. And even at that point, the propagation of the refrigerant is very poor. The refrigerant oiling systems arguably is quite possibly more flammable than the refrigerant itself if you aspirate that oil. Any engineer that's ever unbrazed services before will know that. So we do see a lot of opportunity there.
Yeah, I was going to make the point that I guess one of the, you went into this as you were being in a pioneering role. You went into this with a very belt and braces approach, and I guess you folks need to reiterate that you went in, you really mitigated the risk to the nth degree.
Yeah.
And you're now in a process of rowing back, because I think what we need to do is to make sure for the average contractor out there that they don't. That's probably not the end point. All the measures you put in, but it's a process, isn't it? It's a journey.
It's a process, yeah, and very much with the work also that Chris was doing with TEV. What was interesting when we first started speaking with TEV about coldrooms, because coldrooms for us was the great undone at that point, and it was quite interesting to see how the comparisons of the technical development led into each other and the findings. I think certainly from a DESIR assessment perspective, we've probably even gone above and beyond the assessments that DESIR is asking for, because we want to be belts and braces on what we're doing and make absolutely sure we're doing the right thing. If we're installing a CO2 system, for example, we do it in such a way that we make sure that we're doing the right thing, or water-cooled integrals, whatever they are. Like I say, we're technically agnostic. We want options coming out of our ears in terms of innovation and technology. So, we have really gone to the nth degree. And like I said before, there's a compendium technical document of around 1,000 pages that, as when the time's appropriate, we will share with the industry. It makes we have no benefit in holding on to that information. And we hope that it will benefit the industry, the environment, and our customers alike.
Can I just come in there a little bit as well?
Yeah.
On this?
Go ahead.
Yeah, so I mean, just one thing I would say as well, in terms of one of the key thought processes in terms of developing this product was trying to make something, in terms of the cold room systems that we've developed, is to try and make something which would be easy for the sort of general one-man band contractor to be able to pick up and use, which is an environmentally beneficial product in terms of energy usage and in terms of refrigerant GWP. And what's out there at the moment in terms of using CO2, smaller CO2 condensing units, in terms of the cost and the skill that are required to sort of install that equipment. Getting CO2 qualifications, it's not an easy thing, and the cost barrier of entry is really high. And what we try to do by offering a complete system, so we're not just offering a condensing unit, but by pulling it all together into one package system, is to really take that skill level for your general contractor down, so that this type of technology is available throughout the entire industry. And with all respect to Brian and Asda and the amount of work and resources that they put into that, which is brilliant and pioneering and leading the way, you know, we need to see that filter down to, you know, throughout the whole industry. And that's, you know, that's key to, you know, what we're looking at with the product.
I think it's worth saying also, isn't it, that so I'm just thinking that if anybody just heard the 1,000-page document quote from Brian, that that was to get to the point where we can now have a risk assessment as you're providing for TUV with the system, which is probably 2 or 3 pages, maybe 6. I don't know how many pages. Yeah. But we're all agree. You know, it's a fact that we need to have risk assessment for lower flammability refrigerant. But this idea of providing a template seems to be quite a good way forward.
Yes, yeah, we take a lot of the we're trying to take a lot of the onus away from the you know, the individual small contractor, so that they can feel comfortable in terms of offering this to the general market, to the, you know, to the smaller outlets, and you know, where there is a need for, you know, smaller cold rooms, whether it be, you know, restaurants or anything. Do you know what I mean? That need this type of need sort of equipment, but at the moment there just isn't an option for them. Well, unless they go CO2, but like I say, the barrier to entry in terms of cost and total cost of ownership, as Brian says, the energy benefits of using A2Ls over CO2, or, you know, or even A1s, just really help, you know, give a product that, you know, hit more of the market.
It's worth saying also that you folk were looking at trying to develop a sort of common standard. Where are we on that route, Brian and James?
So this is the learnings to date, so like we mentioned earlier, are going to be issued to the International Institute of Refrigeration through a presentation, and then take back from that peer-to-peer review from around the world. Then it's really then moving forward with that to see how a standard can be created. Because as I said before, there's no benefit in us holding on to this information ourselves. You know, we're in the business of selling beans at the end of the day, not refrigeration systems, but we also have environmental stewardship responsibilities to make sure that anything that we are developing is done on scale, can be done on scale. And like I say, I don't want to see this to be seen as a decrying other technologies. We need multiple technical solutions in order to make sure we not only meet regulatory standards, but also reduce environmental impacts. Whether that is an A2L or an HFO refrigerant, a CO2, like I say, using hydrocarbons, ammonias, all those types of refrigerants have to all be available to us, like I say, to drive technology, drive innovation, drive competitiveness within the market. And all we're doing here is creating another standard which can actually help move that forward and help move technology forward. But I just jump in with one other point around engineers. So I'm from an engineering, service engineering background. And this is where I get a little frustrated sometimes that the service engineer is out there, has got an incredibly difficult job, especially when the sun comes out in the UK in summertime. And we criticize engineers in terms of doing their job properly, being appropriately skilled, but nobody can actually explain what it's like in the middle of summer when you have 30 service calls to do and you're one person on the weekend. And then we go and layer into that more and more complication with multiple different types of systems that same engineer that already takes that criticism has now got even more to deal with, more complication, needs more training, needs more knowledge. Whereas what are we actually doing in terms of simplifying the situation? Because ultimately those that are affected by that, not just the guys with the boots on the ground, it becomes our customers in terms of continuity of trade, performance, and the cost of these systems to run them is still 50% of our total energy usage. So we have to make sure that the total cost of ownership of any technology is reduced, and also the impact to the service guys is reduced as well to give them a fighting chance.
Okay, now just
Andrew, if I could just sort of chip in there as well, I think in terms of what Chris has and TEV have developed, I think it's important that as an industry, a lot of people on the call here will be working, you know, like we do for the big multiples. where different technologies can be trialed, can be landed. They're working with bigger service contractors who are able to develop and upskill their engineers. The harsh reality is that a big portion of our industry, we're talking about shopkeepers, where cash is king to them. We're talking about the butchers, we're talking about the cafes, all with refrigeration equipment. What TEV have developed to market is a really cost-effective proposition that meets regulation, also reduces energy consumption, and would actually give them an overall total cost of ownership over the life cycle of the system. So I think just from that perspective, I think we just need to be mindful as an entire industry as opposed to just the supermarket world.
Indeed, that's a very valid point. What I was going to say is that for the benefit of the audience, Brian has got approximately 6 more minutes with us before he has to rush off to another meeting. So and don't worry, the webinar will continue in his absence. There's plenty more to get into. We'll be answering some more audience questions, and we'll also be looking in depth at an installation. But I'm going to make use of the last 6 minutes of Brian. First of all, with just a quick question around the leak testing. This could be for James as well. As there's been a couple of questions about leak testing and what you did, particularly with regard to validating the strength of the installed pipe work, because there are worries about poor installation. Were there any special measures in terms of the strength of the pipe work?
So this comes back to, again, something I've been beating the drum on for over 10 years now, is around engineering best practice. So the British Refrigeration Association has documented best engineering practices for the installation of refrigeration equipment. And this is where we go root cause of this challenge we have around the banning of refrigerants, or the phase down of refrigerants, is around leakage. Leakage is not the refrigerant that leaks, it's the system that leaks. Does the system leak? The system leaks because it's not installed correctly, it's not commissioned correctly. So long as the standards are followed as they're already set out by the BRA, so your pressure testing standards, your strength testing standards, commissioning standards, best practice of how you install pipe work to make sure that it's not going to be eroded or abrased at any point of it, of its installation over its life cycle, is where it should be at. Whether it's an HFC system, an HFO system, a CO2, whatever that system is, you follow the best engineering practices. And when your client is pushing you to say, we want it quicker, we want it now, we want it to be turned around overnight, there's an onus and responsibility on the industry to say, we shouldn't be doing that. That's the wrong thing to do from an environmental perspective. As far as the question goes on the installation of this system, there is no difference in terms of strength and pressure testing, but it has to be done correctly and properly. James?
Yeah, absolutely. And I think just to add to that, the adherence following BRA best practice in terms of leak and strength testing over the years, from Asda's cumulative leak rate, which, and I'll use this for new systems, we're looking at an annual leakage of 2 to 3%. Of that, only 0.4% of that overall leakage is connected with interconnecting pipework from the plant down to the fixtures. So it goes to show, if these systems are installed and there's correct time allowed for pressure testing, because undoubtedly we do find problems during a pressure test. That's why we put them on a 24-hour test, so we can actually see fluctuations in pressure. And then we will hone in and we will pinpoint and we will find any small area of leakage. And I think just by adopting, as Brian says, that best practice approach, will reap rewards and dividends for the full lifetime of that system. Okay, right, we've got 3 more minutes. I'm going to take one specific question. This is just for Brian. Don't log off everybody else. So just for Brian, when you're talking about your presentation at the IIR conference, is that the one in July or August, I'm being asked?
I don't know exactly when it's going out. Wave are doing presenting the information, so okay. I don't know if it's July or August, James.
It's a ranking conference.
The ranking conference in July. Okay, that's good. We've answered that one. Right, in the last 2 minutes then, Brian, give us a real quick overview of where you see development going, because we can't avoid the fact you're sitting in front of one of your Mistral systems. How's the virtuous circle between those kind of ducted systems and new refrigerants? How's that developing?
So we already have a new installation using an HFO standard on the Mistral display, in one of our brand new stores. We hope to potentially try and get other innovation into that store as well, but we could take it as far as using A2L packs on Mistral air handling units. And again, it's just a simplification of technology. We've removed so much complication off the sales floor that, to be quite honest, our customers and store managers don't want to see. You know, there's no evaporators, no fans, no drains, no leakage. On top of that, we have vastly reduced volume charge systems. And I think that needs to be reiterated, that one of the benefits of the HFO system is it forces you to innovate and design systems with a significantly lower volume charge of refrigerant for the equivalent linear footage of what we would have done previously. We've certainly got more installations happening this year. Those installations are really working around looking at the belts and braces approach and how we actually pair that back to something that's more appropriate. With 2021 really focused around a much wider scale rollout of this type of technology. We've already changed our specification to the 40 kilowatt back-to-back unit that is still using the 448A refrigerants. But what we can then do is, as and when we change the display cases, those packs are already A2L ready. As we change the display cases in years to come, where those packs are in situ, then we will then move it across to an A2L refrigerant. So we don't have to change the entire system.
So the final question then is, and again, this is one of the ones that comes up often. Have you given up on CO2, or is that still part of the looking forward portfolio, as it were, for Asda Walmart?
I think we've got a phrase. I think they're frozen.
He's frozen, yeah. Brian, are you there? Brian is literally frozen.
I think James is frozen as well.
That's interesting, isn't it? Is it because we mentioned CO2? Hoping that that Brian and James can briefly come back. Perhaps he's got a call. We've never encountered this before, where two people freeze at once. So it could just be me and you carrying on the conversation.
I think they're on. Yeah, well, I think they're on the same site, aren't they? So.
Oh, they're on the same site. So perhaps
yeah. So if they've got,
they'll
be back shortly. I guess it's just an internet interruption they have.
Yeah. So we'll see whether or not we get the question answered from Brian, or whether we carry on.
Can I come back to one of the points that was just being spoken about?
That would be good. Yes.
Yeah. So I mean, one of the points that was being discussed was sort of like, you know, pressure testing and things like that. And I just wanted to mention something about the cold room systems that we're offering. Is that they run on an expansion line. So the actual high pressure part of the system, from the compressor that goes through a microchannel heat exchanger, and then it comes out and that goes straight into the electronic expansion valve inside the condensing unit. So the interconnecting pipework and the run through right the way through to the evaporator is all on the low pressure side. So on that side, it's actually easier in terms of pressure testing within the regulations. I just thought it was something that was worth sort of mentioning. That it actually isn't any harder, it's actually easier.
Thank you. There'll be other cold store questions coming up after the break. Brian's back. We were worried about you then.
I don't know how much you caught of that, Andrew. I think you probably
none of it. You froze as soon as I said CO2. The world stopped.
No, all I was saying is that all other technology is absolutely is developing, is innovating, whatever it might be. It's just at the moment where we've developed the HFO Mistral system, it's the thing that's adding value, and not financial but sustainable value through a lot of number crunch and a lot of data. But as and when that technology in other areas continues to innovate and develop, you know, it's arms wide open. You know, we are not just in a single technology space. We are open to a toolbox of solutions. I have to reiterate that. We just see a value in this development right now.
Great. Well, thanks. We will now release you to go to your other meeting. So thanks very much for your time, Brian. And we will.
That's great.
We will carry on the webinar. Thanks very much.
Thank you.
Thanks, Brian.
Thanks, Brian.
I see that James has now come back in the room as well, which is good. We've never had two people disappear at once, but these are the technology challenges that we enjoy. But you're back just in time, James, to as I hand over to Chris for the next part. But we will be welcoming you back. We've got a whole host of questions about the testing and the cold store with A2L journey, which we'll come back to in a few moments. But the next section is where we were hoping to pass to a real life contractor to tell us about a real life installation. But contractors being what they are, Charlie is still somewhere on a site and can't get away, and he's blaming Boris Johnson opening up the pubs because suddenly there's a lot of calls. So he's busy, but fortunately, Chris all along had the presentation. He was going to give that, and Charlie was going to fill in. So Chris is going to fly solo, but this is a chance to talk about a real life installation. So I'll move off onto mute, and I'll give you the floor.
Okay, thank you. Here we go, just a few seconds to get started again. Come on. Here we go. It's just hopefully everybody can see that. Right, okay, so here's just a bit of information on our first A2L cold room installation. It was at Rutherford Organic Farms. It was installed by Keep It Cool Refrigeration, Charlie, who unfortunately can't be here. Because he's busy opening pubs, I think we'll forgive him. And the equipment was supplied through one of our long-standing distributor partners, Heron Hill. So Rutherford Organic Farms, a really brilliant business with environmental sustainability really running through its core. What it does is it supplies 100% organic vegetables direct to consumers. The ethics and ethos of this business are clearly second to none. I'll be honest, having read about them, I'm trying to sign up. I'm currently on their waiting list, but they're that busy. Anyway, obviously, key to their business is reducing their carbon footprint where they can. So refrigeration is obviously key in their plan to reduce their carbon footprint. They've previously invested in CO2 systems, which, as we all know, are not cheap. So they're clearly keen to try options which reduce both their refrigerant GWP and their electrical usage. Okay, first of all, I just need to thank Callum Cull for the excellent on-site images that we've got here and the install images. But yeah, so the specific application is for a cold room serving an on-site catering facility for circa 600 on-site staff. And the planned opening date for this is September. Obviously, the cold room needs to be prepared beforehand. So the story of this goes, I was first contacted by Charlie at Keep It Cool because he'd seen one of my articles about the potential use of A2Ls in cold rooms. Charlie informed me that he and Rutherford would be interested in trying out an alternative green solution for CO2 refrigerant. So we had a look at it together. It was about 2.4 kilowatts and fairly standard refrigeration conditions on a 22.5 meter pipe run, which charge levels against the room size, and everything looked good. So we agreed to move forward with the project. So clearly the installation went ahead, and Charlie fed back to us some really great comments, which he would tell him himself, but I'll go through it. The refrigerant charge information that we put through, that was all accurate and correct. He was happy with that. That went well. The electronic expansion valve was easy to adjust, and with the supplied screen on the driver, that made it easy. Wiring wasn't a problem. That was no problem at all in terms of install, very sort of standard. Pipe work was very similar. Obviously, yeah, you needed to insulate both the suction and the expansion line, which is a little bit different, but you know, it was still very easy to do. The expansion valve already being supplied within the condensing unit, and the fact there's no need for a solenoid valve, that made the install a little bit easier. Running amps were clearly lower than equivalent 449A systems that he'd installed in the past, which is great from an energy efficiency point of view. You can see that immediately. The install time, to be fair, he said, does take a little bit longer, and that's purely through the sort of extra risk assessment work that you need to do. But like I say, all that information in terms of guidance is given within the instructions to make it easy for contractors. But to be fair, that did take more time. There was a clear total cost of ownership benefit against CO2. The install cost reductions, you know, the cost of install was massively less than what it would have been for an equivalent CO2 system. And finally, overall, the install went great and there were no problems. So it was all good. So yeah, we've been working with Wave, obviously James, who's on the call at the moment, to really quantify the benefits of over an equivalent CO2 install for a similar system like this. And our A2L solution comes out very positively. From an install and maintenance, energy usage point of view, everything comes out cheaper. So this showed a potential total cost of ownership saving of around about 25% over an equivalent CO2 system over a 20-year life cycle. From a life emissions of CO2 point of view, the initial refrigerant charge of A2L with a GWP of 148 per kilogram is slightly higher than a CO2 direct CO2 system, obviously. However, this difference is so small, it's almost insignificant compared to the emission savings which are achieved through the reduced energy usage. During its 20-year life cycle, emission savings calculate to around about 28%, which is, you know, a big change. So this, I believe, shows the real benefits that can be achieved through A2L refrigerants. Now, what I'm not saying every refrigeration application should switch to A2L. That's not the case. CO2 and hydrocarbons all have their place in reducing the industry's refrigerant GWP, where we all need to meet our F-gas regulations. We at Master, we have products that use CO2 as a refrigerant. So I'm not going to say, you know, that we dismiss CO2 altogether. However, I believe in cold room applications and potentially other applications as well. For cold room applications, A2Ls and the A2L system match for cold rooms is the best solution in terms of total cost of ownership and CO2 life emissions in this application. Okay, and now it's back to you, Andrew.
Fantastic. Thanks very much, Chris. So we're at that point in the proceedings where we've got about 25 minutes to go. We've got a raft of questions. Keep them coming in, folks. And what we'll do is we'll try and knock off a few specifics, and then we'll move into a little bit more of a general discussion, I think. So first of all, a couple of little public information statements. So thanks to the audience for sending them in. Standard to follow for strength and pressure testing is EN 378.
Yeah.
This is mostly if a contractors, or you're dealing with contractors, I think, and the contractors are looking in. Lots of information, supporting information for you. Also, the IOR has got a series of safety guidance notes, safety coded practices for flammable and lower toxicity refrigerants. A2L, A2, and A3. So contact the IOR for those. And then the BRA's brazing standard is currently being rewritten, to accommodate the revision of EN 14276. And as this is an industry notified body recognised scheme for jointing, that's going to be a key one. So that's currently being rewritten. That's BRA. What else have we got? This is one for James. BRA is again developing guidance on risk assessments and DSIA. Have you been feeding in your results, or are you working with them on commercial systems?
No, we haven't fed in yet, but I think it's important, I think, to actually acknowledge and give credit to Business Edge. We, as in the Asda stakeholder team, have been working closely with Kelvin Kelly of Business Edge to develop the DSIA risk assessments, and it's the same consultant who TEV have been engaged with. Now, there's linkings to the BRA from those channels, so at an appropriate junction, of course, we will engage. The technical compendium that Brian spoke about some time ago, that will be released to industry, because it's critically important that it is critiqued by industry experts, because at this moment in time, although our stakeholder group is quite large and varied, from contractors, consultants, to manufacturers, to end user, to specific health and safety specialists, it is important that the work that we have carried out is critiqued by a wider audience.
Can I just come in there as well, just a little bit?
Yeah.
So I'm actually, I'm deputy chair of the equipment and components section of the BRA. So I'm quite close to the BRA in terms of what's involved, obviously BRA and FITA. So obviously I'll be feeding in that way. The other thing to say as well is that Business Edge were actually involved with FITA in developing some of the risk assessment work that they've been doing. So it's the same consultancy so there has been a link right across from there.
I think it's worth restating, isn't it, with A2Ls, risk assessment is important, but don't be afraid of that element. It's not something to be too frightened of, shall we say. I think as soon as you hear the word DSEER, we all know what that refers to, the E is explosive. The danger is that people go, oh, this is something to worry about. But as we've heard today, and as all these guidance documents show, there really is, you follow due process, these refrigerants are not to be feared. Can you nod, James? Yeah.
No, it's absolutely true. I mean, any refrigerant, they should be treated with equal respect and specific respect to whatever their properties may be, whether or not they're toxic, flammable, mildly flammable, or high pressure.
Okay, and as we talk about BRA, we just had a note in from Martin Cooper, who says the next specific risk assessment guide will indeed be on commercial refrigeration. So it's all pointing in the right direction. That the industry is moving ahead as one, which is good to hear. Couple of specifics for Chris. Will you be able to use electric evaporator defrost?
Yes, that's fine. Yeah, that's not a problem. In terms of lighting in terms of creating something which is, to create a spark or something, the electric defrost, the fact that you've got a heater in there, which is, within the evaporator itself, that's fine. In terms of the electric defrost, we're using electric defrost. In fact, that's the way we do it.
Brilliant. I'm really enjoying this, the feeling of a live debate, because I'm getting corrected when I say something wrong. So I've just been duly corrected. So we should note that in terms of explosive, all refrigerants come under DSEER, but the difference with A2Ls is the lower flammability. So there you go. Duly corrected, Miriam. Sorry. Moving on. Will your system be available through distributors, or will it come direct from the factory, given the complexities of the design?
So our plan is to sell this through distribution. That is our aim. We want to get this to the widest audience possible. We're a manufacturer in the UK. I mean, ultimately, we want this available through, our distribution partners in the UK, and also throughout Europe as well. We want to spread this as far as we possibly can. Brilliant.
Thanks for that. So I've got one more question specifically for James, and then we'll go on to the more the wider issues. So leak detection in the cabinets, are they solid state units? And have you seen any leaks or false detection conditions due to contaminants?
Right, so great question. We've used two different types. We've used a solid state type, but also an aspirated type. What we've found, we've worked with a company called Stonegate specifically to develop, and what in real life, we've obviously we've gone through the tests, so we know the detection systems work, but we haven't actually come across a real life leak yet within one of these systems.
Ah, excellent.
So what I can offer as part of the compendium, we've certainly worked towards different leak detection thresholds from low level up to high level, and the compendium we speak about, we'd be more than happy to share the set points for the leak detection system with wider industry. Definitely, this is what a large part of this activity in building up a technical compendium's been about. It's not to keep ownership amongst the stakeholders. It's there for industry, and it's there to be critiqued by industry as well.
And if I can just come in as well, just quickly, just on the cold room systems that we're offering, we actually give guidance in terms of leak detection within the instructions that we'll be publishing, and also information in terms of what the process should be for end users and installers in the event of a leak. So that'll all be in there in terms of information and guidance.
I guess I should ask, is the system available now if one wanted to buy one today, or do we have to wait for the system?
Can I say that again? Sorry.
Do we have to wait for your system, or is it available now today from you?
It's, yeah, I mean, if you make inquiries through distribution channels, and then we will be able to make it. I mean, it will be available on a lead time. Let's put it that way. There will be a lead time availability somewhere in the region around sort of 6 to 8 weeks, something like that. Where we are eventually, you know, once we get you know, distributors on board and stocking the product, then it will be available on a much more you know, much more freely. But at this moment in time, yeah, you know, as a manufacturer, we have to work on our manufacturing lead time.
No problem. All the distributors can direct their emails to EV.
Oh yeah, if they want to hold these things in stock, that is brilliant news.
Putting people together, that's the beauty of this forum. Okay, let's talk about cold rooms in general. There's been a couple of questions on it. You sort of get the feeling that this is, we've gone past an important barrier here with cold rooms. Is that how you feel? You feel you know, this is one of the more difficult solutions to come up with, at the smaller end. You know, what's the feeling of moving forward now with A2Ls?
For me personally, I think it's all about having, and I think I said it in the piece about the keep it cool installation, is it's about having the right technology for the right application. You know, there are situations where, you know, A2Ls potentially are not the best solution. You know, and you will find that, and you know, and you use other technologies. I think that there is going to be a mix. It's all about having the right solution for the right application, and I think A2Ls very much have their part to play in that. You know, in the future of our refrigeration industry.
This is a genuine question. Does this complete the applications for A2Ls, or are there still some out there that need development? Neither of you might be able to answer that. I don't know. It's probably one for you, James.
I think, I mean, talking from a cold store's perspective, as Chris intimated there, if we're talking a large distribution warehouse, where we'd have, you know, a room duty well in the hundreds of kilowatts, quite honestly, an A2L, it's not going to be suitable unless it's connected to a secondary arrangement. So it's not it's in no way, shape or form a silver bullet. And such applications like that, you know, you know, as a consultant, my initial thoughts would be, well, you know, we'd either have to look at a CO2 system or an ammonia glycol system or a pumped ammonia system. It's certainly not a silver bullet, is what I would say. But it adds very nicely to our industry toolbox of technical solutions.
That's a very equivocal answer, which is what we want. What we're trying to provide here is, as Brian said, technologically agnostic. And I think the less we have one faction fighting against another, the better. But that's just me. Question for Chris specifically on electric defrost. Do you limit the heater temperature to the auto ignition temperature, which for R454C is 444 degrees?
Yeah, it doesn't get there, but yes, we are. Yeah, we do.
Okay.
I'll chip into there, Andrew. We've actually limited on the freezer cabinets that have been installed by Asda. We have limited the heater temperature to fall below the auto ignition.
Okay, good. Thank you. Availability. I mean, it's probably not necessarily a question you can answer, but that question always comes up. Is we talk a lot about the ultra low A2Ls. Are they readily available? I suppose your answer would be, well, we've managed to get enough to work with.
Yeah, so there is stocks of it around within the sort of refrigerant distributors. I can't say, I mean, distribution will be able to get hold of it, in terms of on a lead time, and I'm sure, all distributors, as the need for A2Ls grow, they will start to hold it in stock more. But I do know that the refrigeration distributors are holding it. It is available, and they will sell it through, and then it'll be available through the wider distribution. So it is available. You can get hold of it. It's not that hard to find.
Whenever we discuss new refrigerants, alternative refrigerants of any type, there will be questions along the lines of availability, price, training, and we've talked a little bit about price, and it's not really the time to talk about those, but availability certainly does not appear to be a problem. So then we come to training, and when we've had previous discussions about A2Ls, we've recommended that contractors should seek out flammability courses. And I think you said that in your presentation, didn't you, Chris?
Yeah. So the likes of Business Edge and Cool Concerns, they all have, and I'm sure other training providers as well. They already have fairly, quick and easy and low cost courses available. And for using A2Ls, there's not a great deal of skill uplift that is needed, but you should certainly take that course. But like I say, it's not a big expense, and it's pretty quick. It's not a lot of, and these things can be done almost over the internet as well. I don't think that, you can do these things, over Zoom. These courses, I believe, are available. So it's,
it's probably worth revisiting your slide from your installers the installer who clearly wasn't phased by the process, comfortable with it.
Yeah, he was really comfortable. I mean, he approached us and said, this is what we want to, this is what, he'd been involved in doing similar things in the past, I think, on other sort of hydrocarbon refrigerants, and I think he's also been involved in gas, installing gas systems and the like. So he was very familiar with it, and very, very comfortable. And that sort of helped in terms of us working with them up front, that they knew, and looking at the install, and you can see, the hazard labels all correctly placed and everything else, that he's done a great job.
Good. So again, feedback from the audience to say that established training incorporating A2Ls is in place, including some of the names you've mentioned. The only contractor is watching. There is nothing to fear. There is a question about, maybe one for James. Again, I said it always comes up. Costs. So refrigerant costs at the moment, is A2Ls any more expensive or much more expensive than HFCs or CO2? I guess you're going to say it all comes down to Chewy.
Yeah, well, are we talking about gas price or system price, Andrew?
Well, that's the question, isn't it? What do you think the correct answer is? It's going to be system price, isn't it?
Yeah. Well, let's talk about refrigerant price, actually, Andrew. I mean,
okay, let's talk about that.
Gas price of CO2, we'd probably look at sell price to an end user of £2.5 to £3 per kilogram. Typically, stake in the ground HFCs, depending on the contractor and the relationship and power they have through procurement, you're probably looking at £30 to £35 per kilogram of your 407 and 448, 449 range of gases. The last conversation I had with Chemours about this, and bearing in mind it is a similar price, but I wouldn't like to quote a figure because obviously, there's a specific distribution channel there. As I understand it, we'll be looking at an uplift of 10 to 15%, but I couldn't be held on that.
Yeah. Broad brush is fine. Yeah.
From a system perspective, it depends on the end user. So we don't set strategy, an end user sets a strategy. In Asda's case specifically, they look to mitigate risk and have multiple small system sizes. as opposed to an equivalent sized retail store. Another retailer may very well use 2 booster CO2 systems. I'm quite confident in stating this. From Asda's perspective, it's all about de-risk. For example, if they had a store with 2 booster systems and they lost one of those systems, they're effectively losing the ability to trade from 50%. So the Asda model is generally 4 to 5 medium temperature pack systems of around 80 kilowatts capacity and 2 low temperature pack systems circa 30 kilowatts. If we were look to overlay a CO2 offering to Asda based upon effectively 8 or 9 small pack systems, it wouldn't be cost effective whatsoever. Asda are very keen to maintain the infrastructure that they have, because they don't have the associated on costs such as additional steel work, additional builders work, the initial architectural design. They're very much of a mantra of low cost, best quality, high energy performance, and part of that is short refrigerants, short service routes as well. That's why they like their multiple solutions, because they can more often than not, they can directly locate the refrigeration plant directly above or in the vicinity of the fixtures that they're cooling. But so it would be wrong to, so if we did an analysis, we'd have to look at CO2 being delivered in an alternative platform to Asda, which would, to have multiple CO2 systems, the cost would just spiral out of control. But again, that would be a decision for Asda as a retailer to take, which we wouldn't influence. It's how they gauge levels of risk, specifically trading risk.
One thing I would say, if I can just jump in quickly, is, and I would say this, I would very much encourage any contractors that are interested in looking at a price comparison, just in terms of the base equipment, to contact their distributor, make an inquiry and, do their own comparison in terms of, getting the cost of the CO2 equipment up front and getting the cost of an A2L cold room system in terms of the cost. You can look at the energy and everything else, but if you just want to see how much it would cost to do an install, because I know from a lot of contractors' point of view, that's what they're interested in terms of selling to their, to their end clients. Go get a quote. Go to your local distributor and get a quote, and see what the difference is for yourself.
Indeed, and the point has been made from the audience that really the charge size that we're talking about for the cold rooms at least means that it really should be about the system price rather than just the refrigerant price, because there's not going to be a lot of refrigerant being used, and that's not the most important part. So
in the system, it's going to stay in the system as well.
Yeah, and it's got to stay in the system. Indeed. So thanks for that. So now we're at the point where there's just 2 or 3 minutes left. So it allows me to do my final roundup question to you both, which is, what one thing would you say to the industry audience out there to take away from today? It's very easy for me to ask this same question each time. Not necessarily so easy for you to answer it. But what's the key message? So I'll start with James.
It's simple. Embrace change. Embrace change.
See, a one sentence answer doesn't help when I'm trying to do my rounding up bit. You've got to give me 2 sentences.
Okay, well, let me expand on that then, Andrew. As an industry, we all need to embrace change. And I'm talking the holistic wide industry here. The theme this morning is A2Ls, and I'm talking specifically about the small end users, the one or two owner shopkeepers, smaller contractors who are out there. The reality is that A2Ls they're going to serve a fantastic place in the market, specifically for the smaller end users. They operate very similar to standard HFC systems, but there's still an element of, when I say embrace change, it's the overcoming the apprehension connected with fear. And that fear exists whether or not a refrigerant's flammable, mildly flammable, toxic, or high pressure.
Yeah, so change is coming, and it's down
It's
to
here now.
the
It's here now,
contractor. Yeah,
Andrew.
it's here now, and it's down to the contractor to sort out what that change means for their client. And I'll say it so you don't have to. The sort of is it one option versus the other option doesn't necessarily help. What we need to do is come up with.
It's not even an argument, Andrew. In my perspective, it's every single refrigerant that's out there. It's got a place, and often that place can be determined by an end user's refrigeration policy or strategy, which will vary massively from one end user to the next. But there is no one size fits all solution. There's not one's better than the other.
Thank you. Okay, Chris, over to you.
Yeah, I mean, it's along a similar theme, really. The change is there, it's happening now. Another phase down is coming at the end of this year. So change has to happen. Obviously we had the introduction of 448s and 449s give a little bit of breathing space for the industry within the F-gas regulations, but we need to move beyond that. And it's, as I've said before, it's about picking the right solution for what you've got. We make products for CO2. This is just an addition to the suite of products that we're offering, and we think this is really the right solution for cold rooms. It's good. It's best in terms of energy consumption, best in terms of maintenance, and also in terms of initial install. So it kind of wins all round in terms of this particular application. So yeah, just have your eyes open. Don't take your word, don't take our word for it. Go and get quotes yourself, and learn about A2Ls from other sources as well. And listen to all the arguments and make your own decision. And yeah.
Thank you. Yes. So the big summary will be information is key. There's lots of sources of information, one of which of course is RAC, and we've very much enjoyed having these debates. We can have as many debates as you like, as long as someone comes and helps us out with the support. On that note, thanks very much to TEV and to Chris and Andrew behind the scenes for allowing this to happen and for presenting in a very interesting fashion. Thanks to the panelists. James still here, Brian off on another call, sorting out the Walmart estate across the world. Thanks to him. Thanks to you in the audience for tuning in, but mostly thanks to you for making it a very interactive session. We've dealt with over 30 questions in that time. If you have further questions, then feel free to keep typing away, and we'll get them to the right people. These slides, I think, I can't speak for Brian, but hopefully Brian will allow. I'm sure you will allow them to be available to delegates after the show. It's like we're in theatre. After the event, but it just remains for me to thank you all, and we will see you again soon. There will be a write-up. There'll be a highlights write-up pretty soon, and then we will make the recording available when we've tidied it up, taken all the ums and ahs out, and that will be available hopefully within the week. Thanks very much then, and we will see you soon. Thanks all. Goodbye.
Bye.
Bye.